en panique, tout le monde...
Welcome back to Geology Watch. For thousands of years, Mount Etna in Sicily has been a symbol of power. A spectacular, fire-breathing mountain standing over 3,300 meters tall, it is in an almost constant state of eruption. It is Europe's largest and most active volcano, drawing tourists from around the world to watch its fireworks. We see the headlines every few years: the lava fountains, the ash columns, the glowing rivers of molten rock destroying buildings. But what if the lava is not the real danger? What if the spectacular eruptions we see are just a distraction from a far greater, silent threat? Scientists have just confirmed, using new underwater technology, that the real danger at Etna isn't what's shooting up, it's what's sliding down. The entire side of the volcano is slipping into the ocean, and a new study reveals what happens when it finally lets go. Before we explore this terrifying discovery, if you find these geological insights critical, please take a moment to like this video and subscribe to Geology Watch. The primary threat is known as flank instability. Mount Etna is not a solid mountain of bedrock. It is a colossal structure weighing billions of tons. But it is a loose pile of volcanic rubble, ash, and ancient, fractured lava flows, all stacked on top of a weak, unstable foundation of marine sediments. Because the eastern flank of the volcano is not supported by any mountains, it faces the open Ionian Sea. It is slowly bulging outward and sliding under its own immense weight. This process is called gravitational spreading. The wet, soft clay and sedimentary base beneath the volcano provides almost no friction, acting like grease, allowing the massive flank to creep toward the sea. For decades, scientists have known this was happening. GPS stations on the slopes of Etna confirmed that the entire southeastern flank was moving several centimeters per year. Until recently, this was a scientific mystery. Was this movement just shallow gravity, the top layers settling? Or was it something far more dangerous, the entire body of the volcano being pushed from within? Now we have the answer. A recent major study published by an international team of geoscientists in late 2024 and early 2025 deployed a new network of high-precision acoustic transponders on the seafloor, miles off the coast of Sicily. These are geodetic stations that measure their precise distance from each other using sound pulses. Because GPS does not work underwater, this was the first time scientists could track the volcano's movement below sea level. The data they received was alarming. The results confirmed that the sliding is not just a shallow surface creep. The entire underwater base of the volcano, extending for miles from the coast, is bulging and moving in unison with the flank above. This proves the flank failure is deep-seated, involving the whole side of the volcanic edifice. But what scientists discovered next was the smoking gun. In May 2017, this underwater network detected a sudden 4-centimeter slip over a period of just 8 days. This slow slip event was not a normal earthquake, and it was not silent creep. Crucially, it occurred just after a magmatic intrusion, a buildup of magma inside the volcano. This confirmed a direct one-to-one correlation. When magma builds up deep inside the volcano, the entire flank bulges, destabilizes, and accelerates its slide toward the sea. The volcano is not just erupting. The magma pressure is acting like a hydraulic wedge, literally pushing the side of the mountain outward and lubricating its base. This means every eruption, every buildup of pressure is not just a risk for a lava flow. It is the potential trigger for a catastrophic structural failure. This changes the entire hazard assessment for the region. This isn't just a theory, it is a documented fact. The geological record of Etna shows this has happened before. The massive horseshoe-shaped scar on the volcano's side, known as the Val del Bove, or Valley of the Ox, is the remnant of a catastrophic flank collapse. This event, which happened approximately 8,000 years ago, sent an enormous landslide into the sea, triggering a devastating mega-tsunami. The evidence for this is undeniable. Tsunami deposits from this specific collapse have been found across the eastern Mediterranean. The Neolithic village of Atlat Yam, now submerged off the coast of Israel, is believed to have been destroyed by this very wave thousands of kilometers from the source. The current sliding flank is simply the next chapter in this proven cycle. The volcano's more recent history shows this instability is constant. The eruption in 2002 and 2003 was not a typical summit eruption. It was a violent flank eruption that destroyed tourist facilities and was accompanied by intense seismic swarms. Then, in December 2018, a magma intrusion on the flank triggered a shallow magnitude 4.9 earthquake, causing significant damage and injuries, proving the fault systems on the flank are active and responding to magmatic pressure. So what happens when this modern-day flank, now confirmed to be moving both above and below the water, finally fails? The resulting event would be a catastrophic submarine landslide. A section of the volcano, potentially tens of cubic kilometers in volume, would collapse into the Ionian Sea. This would displace a colossal amount of water, generating a mega-tsunami. This is not a distant Pacific-style tsunami. This is a localized disaster with devastatingly short travel times. Models based on this new data show the initial wave would strike the nearby coast of Sicily, including the city of Catania, with its population of over 500,000 people. In less than 15 minutes, the tsunami would overwhelm the city's port and coastal neighborhoods. But the wave would not stop there. It would radiate outward across the entire Mediterranean basin. It would strike the boot of mainland Italy in under 30 minutes. It would continue across the Ionian Sea, hitting Greece and North Africa within hours. This single event would create a humanitarian crisis in multiple nations simultaneously. For a historical parallel, one only needs to look at the 1908 Messina earthquake and tsunami in this exact same region, which claimed over 100,000 lives. For geoscientists, this discovery is a fundamental shift in the risk assessment for Europe. The threat from Mount Etna is now known to be twofold. First, the spectacular fiery eruption we can all see, and second, the silent catastrophic slide happening beneath the waves, triggered by the very magma that feeds the eruptions. It proves once again that the planet's greatest dangers are often the ones hidden deep beneath the surface. If this analysis gave you a new perspective on our planet's hidden forces, please like this video and subscribe to Geology Watch. Join us as we continue to explore the incredible forces